So this is a video on how to use Logger Pro. This is the Projectile Motion Video Analysis Lab that we did in class. So the first thing you want to do is make this video nice and large because we're going to be collecting data directly from the video. Now, some key things you need to do before data collection: you need to set the origin. Oh, and if this menu here on the right does not appear when you first open it up, you can click right down here. This will make that menu appear on the bottom right-hand corner. So to set the origin, so let's get the ball in this video. We're going to make the video go back, back, back until the ball is just beginning its two-dimensional motion towards the ground. So what we want to do is set the origin. I already have it set here, but what you want to do is this tab right here that says Set Origin. So I'm just going to move it. So I moved the origin. So let's move it back. So we want to set the origin to be right where the ball begins its journey through the air. Okay. Another thing that's really important to do is we need to scale the video. Now, if you look closely, there is a meter stick on the end of this board because we need to tell the computer what is a meter. You know, what distance is this from there to there? Otherwise, the computer has no idea, no concept of length. So what I did is I dragged the cursor from one end of the meter stick to the other, and now the computer is asking, enter the distance in units that correspond with the distance in the movie. So that is exactly 1 meter, 1.0, because that's a meter stick. So you click OK, and now the computer has an idea of you know, how far it is from one point to the next. All right, so we are now ready for data collection. So we're going to click here where it says Add Point. So just select Add Point. Now you place your cursor. You want to keep this as close to the center of the ball as possible. You want the center of the cursor to be directly in the center of the ball. Okay, so you click. I'm just left clicking here. Click, 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 click. And you want to be as careful as you can. Get it right in the center because this is going to determine whether your data is good or not. Now in a minute I'm going to show you that all of these clicks that I'm doing on the ball are being recorded as position and time data. It's recording the horizontal position and the vertical position of the ball as the ball makes its journey. Now of course the X position is getting larger in the positive direction, and the Y position is getting larger in the negative or downward direction. So I'll just do about 10 more clicks, and then we'll look at the data table. So this is a very, very cool program. Okay, that's good enough. Okay, a cool feature on Logger Pro, you go up here. So there's actually 3 different things that are open right now, but the movie is blocking everything because I made it so big. And you do want to make sure the movie is as big as possible. If you're trying to do what I just did with the data collection on a small movie screen, you're not going to get good data. Okay, so a very cool feature, you go to Page, Auto Arrange, and it will clean everything up for you. So we have the video up there in the left-hand corner. We have our data table. Let me scoot the video out of the way a little bit more. Okay, so we have time. We have X position, Y position. As we said, the X position is getting larger in the positive direction. The Y position is getting larger in the negative direction. Now let's go back to time here. Now notice the time does not start at 0. If you go back to the beginning, or does it start at 0? Oh, it does start at 0. Now, if this is not the case, because frequently what will happen is the data table will set the beginning. In fact, let me go back here. So we go to Movie Options. So I must have already had this selected. So if I unselect this, look what happens. So the time, the very first time, is 2.265 seconds. And I don't like that. I would prefer that our first piece of data be at time t equals 0. Because what's happening here is it's setting the beginning of the movie clip to be 0 seconds, and then when we started collecting data was 2.265 seconds. So to make the start of the data table be t equals 0, you right-click on the movie, go to Movie Options, and then you select here first VA, which is Video Analysis. The first video analysis point defines movie time 0. So click that, and it will set our first data point to be time t equals 0. All right, so we have x velocity, y velocity. Now, as we talked about in class, for projectile motion, which is what we had here, the x velocity should be constant, but as you're probably aware at this point, things in science are rarely perfect, but this is pretty good. So the x velocity, 3.1 meter per second, 3.0, 2.9, 2.9. What I would expect is for this x velocity to actually decrease, because this is a real world situation where air resistance is present. So we're probably going to see that to be true. In fact, if we look over here, let's see. So here is our x. This is velocity, and so velocity in the x, and then blue is velocity in the y. What I want to do is change this, and let's just take a look at the position versus time graph. So the way that you can change what's on the x-axis very easily is you right-click on the graph, you go to Graph Options, and we're going to unselect x velocity, y velocity, and we're going to select x position, y position. Now, another way you could have done that, you could have gone up to Options, and you can get Graph Options from there. You could do the exact same thing. Another thing you're going to want to do, so I don't really like the scaling on this graph. I'm going to make, let's see, so our values here, so that's 5. So why don't we go up here and just click up here, and instead of that being 4, let's make that 2. And then instead of this being -8, why don't we make this be -4? Okay, so this is a nicer graph. Now here we have a position time graph. We talked a lot about that in the first few weeks of school. The red dot represents x position, the blue dot represents y position. And this should start making sense to you. This should make a little more sense to you than it did a couple weeks ago. If we look at this graph of x position as a function of time, for the most part, that's a straight line, which tells us that the velocity in the x direction is constant. Now, for the y direction, you can see that there's an increase in the slope. So at the start of the graph here, the slope is pretty much 0. If I drew a tangent line right there, the slope is pretty much 0, and then gradually gets bigger, bigger, bigger in the negative direction, which tells us the y velocity is increasing. So I want to show you how to get a best fit line. So if you wanted to analyze this line here, put a best fit line through these red data points, what you do is you highlight the data point. So just left click and drag. You're going to highlight the data points, and you're going to go to Analyze and do a linear fit. And this is super cool. Oh, it's asking us if we want x or y. We do want x. Okay, so what this is giving us is it gives us a lot of information about this graph. So we have a best fit line here. It's giving us the slope as 2.497, which would be the average velocity in the x direction. So what else? We don't want to do a best fit line on this because the y position, when you plot y position as a function of time, that's not going to give a straight line. Okay, so let's change this graph now. Again, so you go to Graph Options. Let's go back and take a look at x velocity and y velocity. We'll just do both on the same graph. Okay, now we're going to want to fix the scaling here. So let's see, we'll put this at 4. That's a little better. And we'll put this at, let's see, -6. A little bigger, maybe -8. Okay, so that's pretty good. Now let's do a best fit line for both of these. So I'm going to do a best fit line for the x velocity. So we have x velocity in red. So you go Analyze, linear fit. We're going to do it on x velocity. Okay, so as I said earlier in this video, there is a decrease in the x velocity, and you can see that from the slope. We have a decrease in the x velocity, and my guess is that's due to air resistance. The x velocity is only constant when there's no air resistance present. All right, now let's do, so we have a slope here of negative 2.1. So on a velocity time graph, that's the acceleration in the x direction. Okay, let's do a best fit for the y velocity. So we're going to drag across, analyze, linear fit for the y. Okay, and so here's what we have. So we did a linear fit. Now in a perfect world, the slope of this should be negative 9.8. This is not bad at all. In fact, the last time I did this, I got less than 9.8, which I just, again, attributed that to air resistance. But with the data that I just collected in this video, we have an acceleration in the y direction of negative 10, very close to the acceleration of gravity.